Hello and welcome to the Infrastructure Continuous Compliance mini-series. In this mini-series, we are going to have 3 episodes, and we will be looking at an open and modular reference architecture. In this episode 1, it's going to be about the reference architecture itself. In the upcoming episode 2, we're going to apply this reference architecture using one example. In the episode 3, we're going to look at the example being implemented and working in action using a demo. That's quite a lot to go through, so without further ado, let's get started. This is a classic compliance challenge depicted using a diagram. We'll have the x-axis representing the time, we'll have the y-axis representing the level of security. From the left-hand side, we may have the first audit, and we have completed all the remediation actions. That's fantastic. But we're going to introduce new features to our applications. We're going to introduce new applications into environments. The actual state and the desired state will deviate. Most of the security teams understand and acknowledge the gaps, but often those gaps becoming problems to be fixed for the next audit. This is the same diagram, a much better looking version of it. Over here, there are a couple of things happening. We have a preventative controls preventing if there's anything non-compliant from being introduced into our environment. And we have the detective controls and responsive controls continuously looking for if there's anything non-compliant. If it finds anything, it's going to go back and change that resource back to the compliant state. With that better looking diagram in mind, let's look at the same workflow through the lens of an infrastructure engineer. For instance, this is me, Ken. I'm writing infrastructure as code to build my infrastructure on Google Cloud Platform. For example, Terraform. And I'm going to orchestrate my Terraform code using a CI system, continuous integration system. And over there, I've written some policy evaluation unit tests to test my code. If my code fails the unit test, it's going to tell me why it was failed and what am I going to do to fix my code. And over time, I'm going to write better code because I don't like my code to be failed by the unit test all the time, right? If my code passes the unit test, great, it's going to go ahead and deploy. Moving to the right hand side, I'm going to have the same set of policy evaluations, but orchestrated and built on different systems. This system is going to look for if there's anything in my existing environment that's non-compliant. If it doesn't find anything, that's great. It's going to produce a report with timestamp and give it back to me. If it finds anything that's non-compliant, and it's going to fire up another process, such as automatic remediation. Here we are. This is the reference architecture that made the previous workflow possible. There is quite a lot of information on this slide. What I wanted to do here is to take you through the thought process of building this reference architecture. You can always refer back to this video, or you can take a screenshot of this slide. So let's start from the top part, the directive controls. The core of the directive controls is the technical control library. There are several things you can consider to build your own technical control library. Here's the list of representative ones, such as threat landscape, such as your internal and external compliance requirements, such as industry best practice. All of those can be combined and using a control mapping practice to build your own control library. Once you have the control library, you can go ahead, design and build your preventative controls, detective controls, and responsive controls. Like we talked about before, you may have infrastructure as code as input. You can also have SDKs or console as input to build your infrastructure. With infrastructure as code, you could use the infrastructure as code constraint, such as the unit tests we've written before on our continuous integration system. Obviously, you can also use organization policies in GCP or IAM permission controls to control what can the CI system do. And the same control will be effective for the SDKs and the consoles as well. For the detective controls, we're going to use Security Command Center. Security Command Center Premium version has built-in frameworks, industry best practice frameworks, and benchmarks, such as CIS Foundation. You can use CIS Foundation to benchmark your existing environment. It's going to tell you what are the things you have configured correctly, what are the things you need to fix, and also give you a score. If the Security Command Center finds anything that's non-compliant, you can then leverage our event-driven architecture, leveraging the PubSub and the Cloud Function to trigger your downstream processing. And that really opens up the door to different opportunities and different possibilities. You can leverage Cloud Function to go through the automatic remediation process, or you can leverage the Cloud Function to log a ticket with your existing ITSM system, or use Cloud Function to send a message to your system operations Slack channel. With that, it is the end of episode 1. There are 3 messages I'd like you to take away. First one, with continuous compliance in place, you're going to have reduced risk and also real security. Number 2, because your engineers are going to write better code over time, because your detective system is going to produce timestamped report at all time, the whole process will help you to reduce the compliance and audit cost over time. Number 3, you're going to improve the engineering experience within your organization, because your engineers are going to be a part of the security conversation, and they're going to be a part of security workflow as well. So that's it. Stay tuned for episode 2. We're going to apply this reference architecture using a simple example. Until then, take care and goodbye.